scans and quality check of your code. It's a pleasure to introduce you to Dmytro. I hope you're gonna enjoy it. So let's start.
Hello everyone, it's my pleasure to be here to present you Wake framework. Who am I? I'm Dmytro, Khimchenko. I'm head of static analysis tooling at Aki blockchain, and also I'm auditor at Aki blockchain of Ethereum smart contracts. It's a pleasure to work with such clients as Aave, Axelar, Lido, and Layer 0. And also, our company receives grants from Ethereum Foundation, Coinbase, Optimism, and some of these grants is supposed to, it has been given to us for developing Wake framework, and it is for a reason. Okay, one more time about Aki. We are blockchain security auditors. We also love to develop open source tooling, and we also onboard new developers and auditors to our ecosystem. We are doing it. We are teaching in Czech Technical University, and also we teach at School of Solana. So let's go to the Wake framework. It's framework for testing your smart contracts, your code base. It is done via unit tests, and also it can be done via integrational testing, where we want to test also integrational stuff, for example, with already deployed contracts on chain and protocols. Also, with Wake framework you can fuzz, but I will speak about it a little bit later. What also Wake framework provides is static analysis. We discover interesting and common attack vectors using detectors. We have some common static analysis detectors and also some specific one, for example, with integration of Axelar, or specific one with integration with other protocols. Also, what we have, it is printers. Printers helps us to get an idea of code base and to understand it better. It's really nice to have, it's language server. Actually, we needed to develop it with purpose of enabling Solidity extension. It is called Solidity Wake. You can download it on VS Code, on some marketplaces. Okay, let's go here to compare which tools already are on chain and on community and are developed this way. For example, here you can see Slitter. It is maintained. It's mainly used for static analysis and detectors, but it doesn't have another features. For example, testing, buzzing. Another framework, it is Ape. It is used for testing, and it is also maintained, and it is written in Python. Another framework, unfortunately unmaintained, it is Brownie. It is also Python framework. It is used for testing purposes, and also it provides opportunity to developer to use fuzzing, but with the hypothesis plugin, which is not built in Brownie initial. Also, it is Hardhat, which is written in TypeScript. It is maintained, and it is used for testing, and not. It doesn't have fuzzing. Another framework, it is Foundry. It is written in Rust, and it is maintained. It is used for testing. It is used for fuzzing. It also has It also enables developer to create detectors, but there is no detectors in the current time, which is written in Foundry. And Wake framework, it is written in Python, but also with some parts of this implementation implemented in Rust. It is used for testing. It is used for fuzzing. Also, it has detectors, and also it has its own language server that enables, that gives opportunity to developer to use Wake framework as an extension. We will talk about Wake framework capabilities and extension a little bit later. Okay, Wake stops hacks. Here you can see the table that provides information about which hacks have been found by Wake framework. Some of them are found also by fuzzing and static analysis. So you can choose which approach you like better. Let's go let's go to deployment and testing. How it is done. Here you can see code snippet where you need firstly to import packages from deployment. After that, you need to import pipe types. It is actually pipe type Python types for better interaction with contracts, because it's also enables highlighting of these contracts, and also it reports when a parameter of not valid type is passed to the function of contract. And so here we import account from Trezor. With Wake framework, it is possible to deploy smart contracts directly from Trezor. Here you can see deploy, and also some information about contracts has been deployed. And here you can see testing script. It's a little bit similar, and it is intentional to be in this way. Here you can see the difference between them. Here you can, in deployment script, you import Wake development, but in testing script, you import Wake test. And also by types, you should import in the first and second case. And also testing is also pretty similar. You import account admin, you deploy smart contracts locally to local chain, and you assert some assumptions. So everything is in order. And also, what is really nice, that we have cheat codes in Wake framework that really makes life of developer easier. For example, here, developer doesn't need to rewrite some storage variables. It can use mint ERC20 and mint tokens to his account. Of course, it's in the environment. And after that, we can do some assertions. Okay. What is really cool, it is call trees. Here you can see initial call, and you can see subcalls with parameters. And it's really effective for debugging session, because you don't need to iterate over the whole transaction. In debugging, you just print this transaction and you see all subcalls. And also you can see the place where this error occurred. How does it look like? You run a testing script with the it is run, and here you can see that error occurred, and that we can print all full call trace of the last transaction has been executed. Also, what is really interesting is that you can print some Python state also in the backend mode. So in this way, you can get information from some testing environment and also from local chain. What about performance? We decided to test it on Uniswap v3 codebase. Its initial this codebase tests initially have been written in TypeScript in hardhat. And we took it as a reference. Here you can see some of performance stats. We also use different, let's say, background chains, local chains, as the Anvil, hardhat, Ganache, with different frameworks. For example, Brownie, Ape, hardhat, and Baby. Yeah, and here you can see execution times in seconds. Also, this testing is open sourced, and you can find it in Python testing framework benchmark on GitHub. Yeah, let's talk about Python. What is Python? It is random function sequences with random inputs. How can we imagine it? For example, in unit tests, you write specific case and verify it also on specific case. But with Python, you can do it as a magician. We will see it in code snippet. But actually, what is Python? It's random function sequences. So we run a function in a random order with random input parameters to test how codebase reacts in it and how codebase behaves. Please raise your hands who has ever written a fast test or who knows what is Python. Okay, cool. Let's see. Okay. For example, here you can see a simple unit test where sender is specified here and receiver also specified, and also be passed here specific value. So in this case, it's 1,000 tokens. And after that, it is assertion as commonly used in unit tests. But what we can do with Python, we can randomize sender, receiver, and amount. We can say to our script, please choose from random accounts that are available, sender and recipient, both. And also, you can take a random amount from 0 to 10,000. And please execute token transfer. What is interesting, it is that this pass test also, by default, test cases where sender and recipient can be the same account. And also, it tests that amount can be 0. So how codebase or smart contracts reacts when in token transfer value or amount is specified to 0. In this case is like tested by default, and sometimes developers just forget to test them in unit test. But with Python, it is done by default. Okay, let's go to speak about Python performance. We took the Dallas benchmark, which is initially developed by Consensus. It is we run our Python on one CPU during 20 minutes, and it has been done on 5 mazes, 7 times 7. Yeah, that's this way. Here you can see this type of measures with the bugs that fast test run and try to count these bugs. It can move left, right, top, bottom, and also it has some stop space that it can go like band spaces. Okay, and this is how this function move north, for example, looks like. Here is 8 parameters that fuzzer needs to choose and needs to actually fuzz with random data here and to find this bug. I will decide if, for example, this bug has been found. One of this formula, for example, fast test needs to be in field x equals 5 and epsilon equals 3, and also it needs to choose this kind of parameters, this kind of 8 parameters that can pass this all checks. Okay. Yeah, here you can see the results. Compare it with by RS and with by Anvil and with Echidna. Here you can see some as solidity VS Code extension, and here what it enables you to do with it. You can deploy smart contracts and interact with them. So it is the remix actually on code extension on VS Code. Yeah, and also what is really nice and I like that you can do on-chain contract fetch. You can fork contracts from on-chain, and you don't need to deploy it locally. It's our big framework does it for you, and after that you can play with it. You can pass different parameters there. Also, what it does, it's vulnerability highlighting. During code session, developers can see vulnerabilities and don't need to do it after they finish their work on code base. Also, it provides some printers, which is useful for understanding the code base. And one of these printers, it is inheritance graph. Okay. And here, if you want to try this extension, you are welcome. It's on VS Code Marketplace. And here is QR code. Yeah. Thank you. Any questions? Okay, cool. Guess that's it. Yeah?
How was the reaction of mentioned the release?
Yes. Yeah, 1 minute. About, yeah. Yeah, you say about part of comparison with testing. Yeah, okay. Cool.